So right down here, I don't really love any of that. So I'm just going to put this one right here. The ordered pair, r theta, is the polar coordinate. R stands for radius, and theta is your angle measure, which can be in degrees or radians. So to quickly review, because we haven't done any trig yet this year, if you're starting an angle, this is 0 degrees, right, where my pen is. And then we rotate up, and this is 90. Okay, so degrees I'm not really worried about. Radians I'm a little more worried about. So this is 0 radians. What's this? Pi over 2. So maybe on this one, we'll label it in radians. This is pi over 2. And then when you open up here, this is pi. This one down here is 3 pi over 2. And then 0 is the same as 2 pi, just like in degrees, 0 is the same as 360. The issue becomes when you're trying to plot something like 9 pi over 4 or random pi's over 4. So here's my little hint on this. Anytime you're graphing something like pi over 4, well, like let's do pi over 4. The first thing I do when I'm labeling like something pi over 4 is if my denominator is 4, I'm going to label that 4 pi over 4. That way I have 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. And then 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Which should make sense because that 8 divided by 4 is 2. So when someone gives me something like 5 pi over 4, I immediately think, okay, well, where's 4 pi over 4? And 5 pi over 4 is going to be like 1/6 decimal. Does that make sense? If it's 7 pi over 4, I think, okay, here's 4 pi over 4, here's 8 pi over 4, 7 pi over 4 would be 1/6, 4 8 pi over 4. Does that make sense? So if we're given something like 5 pi over 6, if my denominator is 6, I'm immediately going to label it as 6 pi over 6, and this is 12 pi over 6. So 5 pi over 6, I would go to 6 pi over 6 and go 1/2 back. Does that make sense? So with a fourth, and those are the lines I still have, when I'm dividing into fourths, I have 4 different pi pieces that make up a half circle. If I'm dividing it into 6, I have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. That gets split up into 6 pieces. Does that make sense? You won't hear about 2 pi over 6. Why not? Here's 1 pi over 6, here's 2 pi over 6. Why won't you ever hear about 2 pi over 6? Right, because it reduces to pi over 3. Does that make sense? Speaking of pi over 3, if you're doing pi over 3, you would immediately label this pi. 3 pi over 3, and this would be 6 pi over 3. So you have 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. So anytime you have a pi over 3, even if it's like 20 pi over 3, so this can be more difficult, it's more than a full circle. So you're pretty much going 0, 3, 6, 9, 12, 15, 18, and here's 21 pi over 3. So 20 pi over 3 would be the second quadrant, 1/6 before 20. Does that make sense? So graphing, figuring out where in the circle your radian angle measures are is probably going to be the thing that you most thought. And then you know with the positive angle you go clockwise, or that's counterclockwise. And then for a negative angle you go clockwise. Good? Okay, so to plot a point, we typically with x and y coordinates would always do the x coordinate first and then the y coordinate. With this though, I would do the angle measure first and then we'll get to the radius. So on this first one, this is called the polar axis. That's like your starting axis. And then we're opening up to a 60-degree angle, which would be right around here. So where's 45? There's 45. Here. So there's your 60-degree angle. So you'd open up to your theta of 60, and then you'd go out to the second radius. So do you see here this inner circle has a radius of 1. This next one has a radius of 2. The next circle has a radius of 3. So you'd go to your 60-degree ray and then out to a second radius, and there's the location of that point. And you'd label it 2, 60 degrees. Does that make sense? For a 210, what quadrant are we in? Third quadrant, so that would be 30 degrees past 180. I don't love these photographs. Yeah, I'll give you ones that actually count by, that only have those critical 30, 45, 60s. So we'll estimate a 30 degree 210 would be somewhere in here, and then a radius of 3 would put you right out there. $135 is in what quadrant, Alyssa? What'd you say? Yep, second quadrant, so probably right around, that one actually does work out, it's halfway through. Now this one's different because this one has a negative radius. So what would you guess logically if you had to just...
Go to quadrant 4.
Correct. So this is positive radii that go out on your actual terminal ray. If you have a negative radius, you're actually going to go on the opposite side, in the opposite direction, 1, 2, 3, 4 out that way. So even though it's a 135-degree angle, because it's paired with a negative radius, it's not in the second quadrant, it's actually in the fourth quadrant. I did. You go to the opposite side of it. You just kind of count backwards 4. And then the last one, 270, which is right here, but a radius of -1 would put you back Any questions on those? And then for 5 through 8, we'll go to your radian map. So pi over 4 would be here. And then a radius of 3, 1, 2, 3. Would put you there. Okay, what quadrant is 4 pi over 3 in, Sarah? Nope. Who can help her out? Mike? If my denominator is 3, what should I think about this ray as? No, 3 pi over 3. Because you want it to be 1 pi. So this one would be 6 pi over 3. So 3 pi over 3 to 4 pi over 3. 4 pi over 3 is going to be 1 tick past that. Does that make sense? 4 pi over 3 is going to be a third quadrant angle. So here's 0 pi over 3, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. And then a radius of 2 would put you right around there.
Yeah, not good for us. Yeah. You could, but in PreCalc and in Calc, it's kind of like translating between languages. Like in your French class, your teacher probably wants you to like think in French or think in Spanish. So every time you have to like translate back to English just to go back, it's just time. So we'll be doing so much of radians that we just would prefer that you think in radians. And that takes some adjustment because I know the very first time you ever see these, you usually just convert to degrees. But you definitely gotta get used to that. Did you convert everything to degrees last year? Just for your... Yeah. It's just gonna take you a lot more time. And I think once you like pick up on this, okay, if the denominator is 3 and there's 3 pi over 3, I think thinking of it in that way will hopefully automate that for you a little faster so you're more confident. In 7, your denominator is 2, so I would think of this as 2 pi over 2. And this is 4 pi over 2. So 3 pi over 2 would be perfectly halfway in between that, which is a ray we know usually anyway. So here's 3 pi over 2, but with a radius of -3, we go back 1, 2, 3. Any questions on that? And then negative pi over 4 would bring you back here. And then with a radius of -1, that would... The terminal ray's in the 4th quadrant. Because of the negative radius, though, it's going to pop you back over to the 2nd quadrant. And it would be right there. This one. Well, 3 pi over 2 is down. So 3 pi over 2 would bring you to this ray, but because the radius was a negative number, instead of going out +3, I have to go backwards 3. So because you could have, like on that last one, we had a 4th quadrant angle, but with a negative radius, it put us back into the 2nd quadrant. Because of that sort of inversion of quadrants, there's more than one point that exists right there. What would be another coordinate that would land on top of -1, negative pi over 4? What other coordinates would put you at that same location? Because right now they're using a 4th quadrant angle. What's the 3rd quadrant angle that corresponds to this? Oh, what did I say, 3rd? 2nd. Mike? Yep, that would be the angle. What would be the radius you'd have to pair with that? +1. Does that make sense, everybody? So if you go to the opposite ray and negate the radius, you're at the same point. Yes? So like to Brock's point, this -3, 3 pi over 2, what other point would also be there? So change your angle. Don't use a 3 pi over 2. Right. Use the pi over 2, which is the one that it lands on, and a +3. And that's the same one. Not only that, but you could go to a negative pi over... a negative 3 pi over 2. Does everybody see that? If I did a negative 3 pi over 2, that would have me opening up to here. And I could still use a +3 because it would fall right on that ray. So negative 3 pi over 2, 3. There's an infinite number of possibilities. That's something that we don't have in the rectangular XY coordinate system. If we have an XY coordinate pair on just a regular grid and we have like 5, 1, there's no other version of that 0.51 that would locate us in that same spot. But because this thing has circles and sometimes you go forwards and go backwards, there's definitely a long list of things that you could use. Does that make sense? Graphing these? Okay. So the bottom kind of gets talking about that. So plot the point 260. So let's say 60 degrees is here. And 2 would be right there. So take a minute and see if you can, and there's a lot of possibilities, if you can come up with another representation of that same location other than 260. You got one, Ryan? What do you think? Well, no, okay. -2, 240. Did anyone have anything other than that? I'm sure you did. There's lots of options. What'd you have? Is that what that one was? Why do you say that? So what did you do? Just find the opposite ray? So you went 60 degrees into the third quadrant, 180 plus 60 puts you at 240, and then you just went a -2 to put you backwards.
Correct.
Mike? Okay, so he took it a totally different way. He just went backwards around the circle, -300, which is good, and still kept the +2. And I think you guys just hit both ways of doing this from above. One of them says you can keep the same R, and that's what Mike did, and he just added on a full circle. This is in radians, but we just did it in, or you subtracted a full circle, right? You did 60 degrees and you subtracted 360. You just went around the other way. But you kept your radius the same number because he picked a coterminal. So he's pretty much got the same terminal ray, which is why he can keep his 2 positive. Whereas Ryan, by doing 240, he's got a different terminal ray. His terminal ray is in the third quadrant, but he made his R negative to pop him backwards into the first. Yeah.
But you just keep on adding 360.
Right, so you could keep adding 360 or subtracting 360 to either one of these. Yes. Or if you just add 180 or subtract 180, that's what causes you to have to negate the radius. And that's really what Ryan did. He added 180 and negated the radius, whereas Mike went with a 360 multiple and kept the radius the same. Good? So try 2 now in radians, where you'd either be adding a full circle or subtracting a full circle of 2 pi, or adding or subtracting a half circle of pi. Yeah. So 120 is going to bring us here in the second quadrant. So 2 paired with that, or even a -2 paired with that, that would have us bouncing back between quadrants 2 and 4, where we want to be in 1 and 3. Tori, what'd you come up with? -5 with 5 pi over 4. Did anybody come up with anything different? We'll check that in a minute. Andrew? Anybody come up with anything other than those two? Okay, so Tori negated her R. So she essentially, our terminal ray was in the first quadrant. She came up with the third quadrant opposite ray equivalent, which if your denominator is pi over 4, this is 4 pi over 4. So that would have been 5 pi over 4, which she has. So she has it opening up to 5 pi over 4, but with a negative R of -5, which put her back in quadrant 1. So that's good. So she essentially added on a half circle and then negated her R, which popped her back. Versus, who was my other one? Andrew. Andrew instead went backwards. So rather than going positive pi over 4 to get to that angle, he went backwards 7 pi over 4, which landed him on the exact same terminal ray. So he didn't need a negative R. He kept his R positive because his terminal ray was on top of the original terminal ray. Does that make sense? Nobody had anything different? Like you could go backwards how far? -3 pi over 4? And then with a -5? That would work?